Good morning, everybody, and welcome to the Wolf SSL Live webinar on all things cURL. My name is, with cURL founder Daniel Stenberg, of course. My name is Kajal Sapkota, and I will be moderating this webinar. As a reminder, all attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you'd like to ask the question live, as we do host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I also invite everyone to follow us on Twitter at WolfSSL, as well as all of our other socials. And please feel free to email us at facts@wolfssl.com if you have any additional questions. And now I'd like to give a brief company overview before we move on to the technical presentation. So Wolf SSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open source dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial-style developer support. Wolf SSL was born into this market need with an OpenSSL compatibility layer. Today, Wolf SSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. Wolf SSL is made up of almost 50 dedicated employees in 2021, most of which are engineers. This progress is, of course, supported by a strong partner network that we're very proud of, which includes STMicro, cURL, and Xilinx, for example. Since the beginning, our engineering team has developed several embedded security products, including WolfCrypt with DO178 support, FIPS certification, and a FIPS-ready offering, MQTT up to the version 5 specification, SSH v2, TPM 2.0, a secure bootloader known as Wolfboot, as well as Java wrappers and JSSC support, and of course, commercial support for cURL. All of these offerings are accompanied by a thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to Daniel for the presentation.
Thank you. Hello, everyone. So yes, this is cURL, FIPS, and Windows. And I'm Daniel Stenberg. I founded the cURL project a long time ago, and I work for Wolf SSL, where we offer cURL support. And today I'm going to try to do this in a fairly short and quick and sweet manner, and I'm going to tell you a little bit about cURL in this context, and something about what FIPS is and how it matters here, something about the libcurl API, TLS backends, and how we build cURL for Windows, or can do it. And then, of course, there's room for a Q&A in the end. So if you have any questions about what I'm saying or anything else related to cURL really, or FIPS or TLS, just click the little Q&A thing here in Zoom and ask the question, and I'll get to that in the end. So cURL, of course, to get everyone on board here, cURL is both then a client-side command line tool and a library for transferring data using internet protocols. It is widely used. It supports a lot of transfer protocols. Among the most known and popular ones are these listed on this page. Of course, most popular and most known are HTTP and HTTPS, but it also supports a range of other protocols. cURL is supported open source. We've been doing this for a very long time. I released the first version of cURL in 1998, and we've been polishing and hardening it since then. It's licensed under the MIT license. We support it here at Wolf SSL, where I work on cURL full time, and I am the founder and lead developer of cURL. Continuing. cURL is used literally everywhere, in everything from servers, game consoles, set-top boxes, kitchen devices, TVs, operating systems, a lot of other different things that are very popular in games. You can see a little thing, a few here in the background. It's used in a lot of cars and in virtually every mobile device and tablet too. So all in all, we estimate that curl runs in around 10 billion installations today on the globe. It's very widely used, and it has sort of become a de facto internet transfer API, the library then, libcurl. That's a little bit of what curl. So I'm talking today about curl FIPS and Windows, right? So FIPS in this context. I'm not an expert on FIPS, so I'm not going to get into specific details about FIPS. We have experts on that. So if you have specific FIPS questions, email them to us at wolfSSL and we'll deal with them, because I cannot. But FIPS, in this context, we're talking about FIPS 140, which then is a specific requirement by the US government and other regulated industries, as it says here, basically requiring things on the cryptography parts of a software component. So in the FIPS 140-2 is the current specification, and there's a new one, or actually I think it exists already. It is supposed to replace the -3 one is supposed to replace the -2 one as we go forward. So this is what we're talking about, is pretty much a specification and requirement on the cryptography in the software. And the cryptography in this case is of course the TLS parts when you're using curl. So, and then yeah, that's curl, that's FIPS, and back to the libcurl API, right? Since because when we're talking about curl in many aspects and use cases, we're talking about libcurl and the API that people are then we're bundling libcurl, we're using libcurl in applications and devices. So curl, yes, it supports a lot of different protocols. Here are all the 26 different protocols curl supports, transfer protocols, and it's on top, as you can see in the bottom here, it's also on top of SSH or TLS in a lot of cases, and those use cryptography modules. It also works on a lot of different operating systems. More operating systems than at least I can name without trying really, really hard. And it runs on virtually every CPU architecture you can imagine. And you can build it with a lot of different TLS backends. So a lot of different combinations, right? So there's operating systems, CPU architectures, TLS backends, but there's only one single unified API that libcurl provides for the applications for the world, really. And that is one of the strong sides with libcurl, because when you go with libcurl, you can use that API, whatever platform you're using. Even when you change platforms, you change CPU, you change operating system, you can still use the libcurl API in your application. But of course, I mentioned then the TLS backends. That means that you build curl to use one of these particular TLS backends when you decide, when you build curl to, well, or someone else builds curls for you, whatever, you get a libcurl and it uses a TLS library, one or TLS backend. So you can pick one of those when you build curl, or many of them actually. And in this case, the pluggable TLS backend, that affects us when we're talking about FIPS, because of course you want, if you want that FIPS license, you want it to fulfill the FIPS requirements, you need a TLS library that can do that. And among all those libraries, of course, that curl supports, not all of them are FIPS or FIPS compatible or FIPS ready. And all those TLS libraries that you can select from when you build curl, they will differ in different ways. You know, they will have different features, licenses, maybe performance, they will have different footprints, and they will support different platforms. So there's, of course, a range of different things that you have to take into account when you select your TLS backend. But if FIPS is one of those checkboxes that you need to check off to make sure that you want a curl on your system that is FIPS ready or FIPS compatible, you're limited to basically two choices today. And if we're looking on the left side of this slide, OpenSSL provides a FIPS solution that has been end of life since 2019. Because it's based on the OpenSSL 1.02 version that is no longer the current one. nowadays they're uh, moving all their users to the OpenSSL 1.1.1 series of versions. And the OpenSSL project are, they state that they're planning for their FIPS effort to come back into play and when 3.0 is released. But OpenSSL 3.0 is delayed quite a lot, and I fear that it might not be released until early 2022 or maybe late 2021. We'll see about that. But they've run into a lot of delays lately, so they haven't even released their first beta version for 3.0 yet. So they're behind. And then we have the other solution for FIPS, which of course I'm biased. I'm here today on this webinar, so this is not a surprise to you, but it's the wolfSSL solution, because wolfSSL in the latest versions with wolfSSL, it is already FIPS ready, so you can go with it today, and it's also commercially supported, so you will be able to get exactly that help and assistance on whatever you need right now, actually. And if you would compare feature-wise, maybe I should have had a slide for that. You know, OpenSSL features versus wolfSSL features, they're really very much on par. You really won't find a lot of things that OpenSSL does that Wolf can't. So you're not really trading any features away by going with a wolfSSL. I would say, on the contrary, in many cases, you will actually have a more performant library with a smaller footprint when going with wolfSSL. So those are at least two different FIPS choices you have going forward. Those are the only two I'm aware of that you can select from among the TLS backends you can build curl to use. And if you go with, then you want to have that FIPS TLS library with curl, and you want to build it on Windows. Windows is a very important platform, and it's a popular thing, and it's a common surrounding and environment to use. So how do you do that? It's actually easier than you might think as a first thought. Of course, it requires that you're somewhat developer oriented or minded, but you build wolfSSL first, and that's easy. You can build it actually using several different methods, and then you just build curl, and you specify that you want it to use wolfSSL at build time, and then that's it. It's really, really easy. And of course, you might actually want to have some variants of this, because you might want curl to use more libraries for other protocols or for other specific reasons, like different HTTP versions or other authentications or something like that. But still, this is the basics, and going with these are easy and straightforward. And you can get the commercial help from us at wolfSSL, or you can get the open public forum help on the mailing list or in the forums for wolfSSL. And if you're going just plain into how to build curl on Windows specifically, it is also not hard. And by default, libcurl ships with several different ways to build on Windows. You can either go with a perhaps most popular one, which is using the Visual Studio project files, which is how some users of Visual Studio on Windows will do it. So in this directory called project/Windows, there's a set of pre-generated project files that you can just load into your Visual Studio and build curl, blah, blah. And there's you can also generate a set that is using wolfSSL as a sort of setup from the beginning. So that's easy and more or less just a few buttons presses away. Or you can do it the command line style with Visual Studio that you might want to do if you do it from a script or maybe automated or something. And then you just use nmake, which is the make tool for Visual Studio. And you find the make file in the win build directory in the curl releases. And that is also, and you specify a bunch of options on the command line, and then you run nmake, and 2 minutes later, you would have a curl built with wolfSSL and the specific versions, so the specific options enabled, disabled. You can build, static libraries, DLL libraries, and switch on and off a few different other options and dependencies depending on what you want your build to do. Or you can even go with the MSys2 approach and run configure. And MSys2 is a way to basically run configure, and configure is more the Unix style of building curls. But you can go that route with curl on Windows as well, and you can also build wolfSSL on Windows that way. Whichever of these routes you choose, it's not hard, and you can do it, and you can build curl to use wolfSSL, and then you're just good to go. Everything is fine and dandy. So it's basically all of this. It's not harder than what I've said today. So you want a TLS library that is FIPS ready, and you build your curl to use it, and you build everything on Windows. That's also easy, and then you're basically set for success. And if you're having problems anywhere around this route, you ask questions and we help you out. It's not a big deal, any of this. So you can get your FIPS ready curl build on any platform, on Windows specifically, sure, without a lot of effort, really. If you want more details into anything about curl, or everything curl maybe, then go to this site, because here's the book, Everything Curl. It goes into a lot of details on how to use curl, how to use the libcurl API, and a lot of things around curl. So really get into a lot of things around curl. Of course, a lot more than this little fast thing I've talked about today. If you want to learn even more, if you want to go on the website, you can see it here. This curl.se is the website. If you go to the wolfssl.com site, you can find the products page about curl there, and how to buy support or get help for whatever curl problems you have. Or you just email support@wolfssl.com, and we will help you out immediately. Okay, that was a lot of things. I've talked fast and I've really tried to make this a really condensed presentation. So if you have any questions, I'm ready. I don't see any questions added right now, so maybe I've just been talking too fast, or maybe everything was just crystal clear.
Alrighty. We have, I guess, one question, which is, which library or toolkit does the curl project use for unit tests?
Well, we use OpenSSL, we use wolfSSL, we use BoringSSL, we use LibreSSL, I think we use embed TLS, and we use Russell's as well. So we actually build and run curl tests with, I think, 7, 8 different TLS libraries. So we are pretty sure that most of it works. We don't actually run all. Well, we actually run with secure transport and S-channel as well on Windows and Mac. So I would say maybe even more libraries. So most of them, actually.
Okay, awesome. How much effort was spent to set up and configure tools such as IGTM, CodeQL, Coverity, etc.?
Most of them are really straightforward. So they're actually, we're talking about static code analyzing tools. And I would say that these days, a lot of those static code analyzers are really easy to set up and use in your projects, because they're streamlined and targeted to the sort of the GitHub model of working. So it's basically just agreeing and installing in your project, and it works more or less by default. At least it was very easy for me in the code project. Coverity is slightly different, because they ask you to not use it immediately in the CI pipeline if you use too many commits, as we do. So I just run it manually every now and then, like every maybe twice a week or once a week or something like that. So, but really not a lot of work and effort has been sort of needed to get that going.
Okay. And I'm just going to remind everyone, please feel free to use the Q&A box to ask any questions, as we'd love to answer them. Question here is, does cURL do tests with old Wolf SSL versions like 3.6 to test specific behaviors?
Well, not in the core project, we don't explicitly do that. No, we do a lot of tests with a lot of TLS libraries. We don't cover a lot of different versions of each library. No, so there might actually be some combinations of things that we don't test for.
Fantastic. Does the project have some systematic or systematic way to check for performance regressions like increased memory usage or CPU cycles?
Oh no, that's it's a good question. And no, we don't have that in not any of those actually. But I mean, we don't have any systematic test or automatic ways to detect that. I try to get around to do that more or less manually every now and then, because I'm always interested to make sure that we're not doing exactly that, bloating memory or wasting CPU performance accidentally. And if we do, we should at least do it knowingly and with caution. But it's a very tricky area, and I think that's certainly an area or areas that we can improve going forward.
Fantastic. And then this is the last question we have. Having a lot of platforms to test in multiple CI, um, false positives must be a hard problem to tackle. How do you handle that?
Yes, well, and I think the false positives are really annoying. And I think our biggest problems with since we have around 100 CI jobs per commit, and I think we're adding more now, so I think we're going to pass 100 very soon. But I think the biggest problem is, of course, that some CI jobs will then report failure or turn red without them actually being a problem. And that is really annoying, and we keep working on making sure that we minimize that. But with over 100 jobs, that it tend to happen almost every round. And we tackle it by mostly, when I do it, when I review what happens to commit or pull request, that it turns red. Oh, red, they're almost always red, right? And then I check which ones are red. And then I see that, oh, these two builds are red. And often they're the same ones. So it's just that Windows on Azure or whatever it is. So, and it always turns red, and then if it turns red and red and red and red in many repeated builds, then maybe I will just ignore it. But often I will just check it out, just view the results at the end of the CI build and see what failed in that build and see if that's the same false positive as it has been before. It is a somewhat erroneous method, because it's easy to then miss a new error that might occur on one of those builds. But it's also well, it's pretty much the best we can do right now, I think. And we're trying really hard also to make sure that we go back to these builds and see, is this a particular test perhaps that's always fail in this build combination or on this platform, and maybe work on fixing that test, or maybe disabling that test in that particular environment. And so that we try to do all of that in order to make this as a small problem as possible. But it's a challenge to have everything that going smoothly.
Alrighty, and I think that was the last of our questions. Thank you so much, Daniel, for a fantastic presentation. As a reminder to everyone, this webinar is recorded and will be uploaded to our YouTube channel following the presentation. If you would like a copy of the slide deck, please contact us at facts@wolfssl.com and we'd be happy to send that right over to your way. And if you have any other questions, also please feel free to contact us again at facts@wolfssl.com. And thank you so much. I hope everyone has a great day.